it in my head like
Yeah, you might want to there. Okay, friends, we're going to get started here with this. 8.6 is our last section in Chapter 8, and it's going to be called Modeling with Trig Functions. I have good news today. You want the good news? We're going back to just sine and cosine today.
Okay.
That's good, right? All right. Yeah, I'm not going to get too excited about the last four that we just talked about. I wanted to touch on them and make sure you understood why the graphs were the way they were, why some things were undefined. But today, this is a pretty important little section right here, talking about modeling with trig functions. And again, the functions I really want to focus on today are going to be sine and cosine functions for us. So, that being said, let's see what we can do today. If I can get some tools here.
Go green. Try to.
Yeah, I thought I had it fixed.
What'd you do to it?
Oh, I had a little talk with it. Said some things. Not sure it worked, but I tried.
Is it the computer or the thing on the board?
I think it's the laptop there. This thing's working okay. It just that won't do anything right lately.
Which one?
Well, anyway, I'll start with the essential question here today. The question is, what are characteristics of the real-life problems that can be modeled by trig functions? Again, we're going back to what functions again, kids? Which two that we're good at?
Sine?
Sine and cosine.
Cosine.
Okay. We're going to have something new today. It's known as what's, you guys remember when we talked about period and cycle time?
Yeah.
Okay. With sine and cosine, the period can be found by taking 2 pi and dividing by what?
Absolute value B.
Absolute value B. We're going to talk about a new part today. We're going to talk about interpreting and using frequency. Okay? In interpreting and using frequency right here, this is going to be a new one for you, but very important. All right? We're going to write trig functions with some of the sine and cosine graphs that we're given, and then we're also going to use our Desmos to help fit graphs to points that are sine and cosine functions today. Okay? So guys, first thing we need to know, and this is pretty new for us, pretty important, it's called frequency. All right, I'm about ready to freak out on this thing.
Frequency.
If I lose everything, I'm going to be upset.
Frequency
Okay. What's frequency say there, kids? It's called the reciprocal of the period. It's the number of cycles per unit time or frequency of the period. Now I don't have this right in here. Okay, let's try this one more time.
You got it.
Maybe my tools can work this time.
Knowledge. I can envision the page where all the information is bolded.
Okay, I'm going to write this down here, kids. The frequency, my friends, is going to equal the number of cycles per unit time, but in our case, the frequency f is going to equal the reciprocal period. Remember, the period for sine and cosine was 2 pi over absolute value b. This time, we're actually going to put the frequency down as b over 2 pi here, okay? Because wouldn't 2 pi over b just get flipped around like that?
Yeah. Is the B still an absolute value?
Doesn't necessarily have to be this time, okay? And most of the things that we talk about per unit time, if something happens over positive time, you're going to have a positive number of values all the time, okay? Like if I say something happens 17 times per second, that ain't going to happen negative 17 times per second. Does that make sense to you?
How do you know what the unit time is?
Okay, the unit they're going to tell you, it's like per second or per minute. That'll be written in a story problem for us. We'll look at that here in a second, all right? Here's a fun word, one of my favorite words, sinusoidal. Sinusoidal. The function is sinusoidal. All you need to know, you ever see this word? It's either the graph of a what or a what? It just goes up and down. This is called sinusoidal motion. Aren't waves kind of like this, kids? They always read problems like the waves move in what's called a sinusoidal motion. It just means it's up, down, up, down, up, down. It repeats itself all the time, okay? So it just means it's a what or what, kids? Okay. Recall amplitude, kids. It's the height above or below the midline. What variable represents amplitude again, friends? A. And typically we call it the absolute value of A, right? Guys, period is the time it takes to complete one cycle relative to sine and cosine. What was that formula again?
2 pi over absolute value.
2 pi over the...
Absolute value.
Oh, this is working great today, let me tell you.
X equals negative.
2 pi over the absolute value of b. Okay, and then the midline is kind of like the k value. It's the line that the sinusoidal function oscillates around. So it's just a k value. We'll look at that here in a second, all right? So I think vocab-wise, really the one thing that's really new for you guys is what?
Frequency.
Frequency. Know what that is? And sinusoidal just means it's either a what or what? Okay, let's get talking here. Let's see what we can figure out here. Okay? We're right into our first one. Okay. Guys, anytime we have to model a function, if you can, here's the deal. We have trig functions written as either y equals a times sine or cosine. Guys, what you're always trying to do is find a value for A, H, K. I forgot a variable up here. Which one did I forget?
B.
B. Okay, we're also trying to find a value for B if we can when we're doing these, okay?
What notes did we learn this on?
Probably 8.2. Okay? But what we're going to be doing, guys, is finding values for this. And I think you'll understand this. You understand that A is the amplitude, B affects the period, H is like a movement left or right, and K is really my midline. How far up or down does it get shifted? Okay? All right, so guys, the first one right here. An audiometer produces a pure tone with a frequency of what?
1,000 hertz.
Which is 1,000 cycles per what?
Second.
Okay, there's that word right here again, kids. What is that word?
Frequency.
Frequency of F, 1,000 hertz. Okay? Says the maximum pressure produced from the pure tone is what?
20 milli.
Means the highest it goes is what? 20 millipascals. Okay, we're getting into some heavy stuff here. It says write and graph a sine model that gives the pressure P as a function of the time T. What kind of model here, kids?
Sine.
Okay. All right, here's what we know, kids. There is no left and right movement on this. All right? What they're saying is that this is a sine function, my friends.
Oh, I never saw the
Sine functions kind of start out like this.
We have one.
That's one cycle of a sine function. You agree with that? Okay? We got to figure out the amplitude. If a sine function goes as high as 20, then it must go as low as what?
Negative 20.
Negative 20. So where's the midline going to be at?
0.
So K is really what value here?
0.
Was there any shifting left or right going on? So is there any H value to worry about? Okay, how about an amplitude value? You know an amplitude here? How high up did this go?
20.
So A must equal 20. Is this going to be a positive 20 or negative 20 by the shape of that graph?
20. Positive.
Positive. Okay. If it was flipped over the x-axis, that 20 would have been what kind of 20?
Negative.
Okay. Here's the new part today. The part that they told you right here was the frequency is what?
1,000.
Okay. What we know so far in this, there was no vertical and no horizontal translation. So H is 0 and K is going to be equal to 0. Okay. We need to come up with a value for what? B. Now guys, keep in mind, our frequency F now is equal to B over what?
2 pi.
Well, my friends, to find that B value right there, do you know a frequency value? What can I plug in for F? What can I plug in for f right now? What is my frequency?
Oh, okay. 10,000. I mean 1,000.
So in for f, I'm going to plug in 1,000. That's going to equal b divided by what? Do I have enough information there to figure out what my b value is at this point?
Yes.
What is that b value? What would you do to get b alone?
Times 2 pi.
So b would have to equal 2 pi times 1,000, which is? What do you think, friends? Okay. So here's the deal. Do I have an a value, an h value, a k value, and a b value to plug in?
Yes.
This function can be modeled by...
I really hope I slept in my clock.
Oh, come on. This function can be modeled by the following. And y equals... Okay, what was the a value, friends? 20 times the sine of 2,000 pi times which variable? Times x, right? Because that x minus 0 would just be x. And then do I need to put a plus 0 on the end of that? Okay? You want to see something with what 1,000 cycles per second looks like on a graph?
Do you have to have the parentheses around?
Not necessarily. Not in this case, no. Okay? I always do it because sometimes it says, sometimes your computers are smart enough to take the sine of 2 and turn it into a value, and I don't want that to happen. Okay? Watch this right here. Watch this graph. This is so cool. Okay?
Sinusoidal function. Sinusoid. So it would be sinusoidal function.
What do we come up with? Y equals 20.
Whoa. Is there a space there?
Something ain't right.
Why would it look like that? It looks like there's a space between your 2 and the zeros. Oh.
What do we get? 2,000 pi x?
Yeah.
Yep. There's your graph. Something doesn't seem right here. Am I in the right mode?
Yeah. Whoa. Wait, why'd it go away? Is that not it?
I think so. Although I don't understand. Oh, I know why it's doing this, because it's estimating pi, isn't it? That's why it's off here a little bit. But again, origin 0, 0 should be where it's really at here, kids. And the reason it's not there is because they're calling this 3.14, and it should really be a lot longer than 3.14. Okay. All right. So quiz, what's your frequency known as again?
Pi over b over the whole.
And it's the reciprocal, really, of the what?
Cycle?
Okay. All right.
Knowledge.
Let's try another one. Kids, take a look at this graph right here.
Brainchild.
Go from where it starts at right here. Guys, does this look more like the first cycle right here on the y-axis go down, all the way down, and then back up?
Wow.
Does this appear to look like a sine or cosine function to start? Is it an S-shaped or kind of a U-shaped in that first cycle?
You.
Yeah, starting right here, it looks like a U-shape, so this looks like a cosine, doesn't it?
Go up or down?
Okay, so this would be a cosine function. Guys, if I'm looking just right here at this part, right here,
Yeah.
that's a U shape. That'd be a positive cosine, right?
Correct.
Okay. Guys, what's the highest it gets to?
13.
What's the lowest it gets to?
-5. The mid things we.
-5. So we got to find a midline in this,
No.
don't we?
13.
Okay. What's the difference between 13 and
It's
negative
9.
How about this? The midline is just the average of the highest and the lowest. So what's 13 plus negative 5?
Let's call it positive 9.
Okay, so the midline K right here is going to equal that 13, that high value plus the low, which is what value again? Negative 5.
8.
And then this is all going to get divided by 2. Isn't that 8 divided by 2?
4.
And so the midline happens to be at 4. So if I would go up here, 1, well, it looks like they're going by 2s here, don't they? 2 and 4. So they're going by 2s here. If I would draw a midline right here, if I would draw a line right here about, does that look like the midline of that graph? Okay.
Okay.
So K is equal to what value here?
4.
Okay, you think that this is a cosine graph, right? Okay. Guys, what's the highest point again?
13.
Okay, and the midline's where?
4.
How far above 4 and how far below 4 does this go?
9.
So what's the amplitude have to equal?
9.
Okay. Guys, it's a U shape right here that started at 13, went all the way down, and it completed one whole cycle time in how many radians?
Pi over 4.
Okay, one cycle happened to be, or one period happened to be in pi over 4 units, right? Okay, here's the deal. What's the thing about period? Okay, period again. Okay, what's period equal to again? 2 pi over
Absolute value B.
absolute value of b. What did we just get done saying the period was in this situation?
Pi over 4.
Pi over 4. Oh my gosh. Okay. So this would mean the period pi over 4 has to equal 2 pi over b, doesn't it? Okay, let's talk about this. I could cross multiply here, so wouldn't b pi be the
B pi. Oh. Wow.
wouldn't b times pi be 1 cross product? You like
Did you?
those?
Did you do that on purpose today?
Of course I did that on purpose today. Wouldn't b pi equal, what's this cross product right here? What's that make the b value have to be, kids?
8.
Right?
Okay.
Does that make sense?
I'm gonna trust you.
If I divide both sides by pi, wouldn't b equal 8 here?
Hey, I just you're blocking my view.
Okay. Guys, do we need to talk about any sliding left or right? The answer, not really, because we know it's a cosine. It starts at 0, 0. So here's our function. Y equals. What do you want to throw in for amplitude, friends?
9. Cosine.
9 times the
8.
cosine of, what's your b value?
8.
Oh, this is
You got it.
8x plus the midline on the end, kids.
Plus 4.
Plus 4.
We did it.
Okay, now one thing I would always encourage you guys here is this. When you do write a function for a given graph, I would go in and I would put the function in. And I would see if what you put in matches what we get out here. So I'm going to kind of look at minimums and maximums right here, if you will. Guys got that written down here?
Yes.
Okay, so let me go to decimals. What did we come up with a function here? Was it 9 cosine?
9 cosine 8. X. Plus 4.
Okay.
Wow.
Yeah, this is kind of a mess, isn't it? But guys, just check this out. If I'm going to stretch this out a little bit. Okay, it looks like the lowest went down here to what? Okay, let me go check this other one clear up top here.
Let's go 13. I bet it's 13.
Was 0, 13 one of our points?
Oh, look at that.
What do we want this next one to be right here?
Pi over 4, 13.
Are we right?
We're so right.
Okay. So I would always check in that first cycle your 2 minimums or 2 maximums and a minimum, or check some of those points that they give you in that graph right there, okay? Guys, I'm going to stop there. I'm going to pick this up. I don't think I'm going to send out an online page today. We'll send it out tomorrow. Is that okay?